Hi, I'm Nick Romano, CEO of Deeplite. Thanks for having me here today. This video you just saw is a great example of how our AI technology enhanced the AI processing of a real-time video feed from BlackBerry QNX. In a self-driving car, reaction time is everything. But that self-driving car, a drone inspecting crops, a camera looking for defects in steel, your phone authenticating your identity, this is AI interacting in the real world. This is AI at the edge. To understand Deeplite better, I'd like to start with some key AI concepts to help provide some context. So what is AI, and specifically what is deep learning? Fundamentally, AI is about using computer algorithms to make decisions so humans don't have to. In an ideal world, these decisions are made instantly. It enhances the way we can interact with the things that we use every day. In that self-driving car example, it's the difference between being the driver and being the passenger. In AI, the percentage of time the decision making is correct is what we call accuracy. Accuracy goes from being interesting, a cat or a dog, to being critical, I need to stop this vehicle so I don't hit this pedestrian. It really depends on the situation. But how do we increase accuracy in AI? Like humans, AI needs to learn. This is called training. Training requires a tremendous amount of data to achieve acceptable accuracy levels. So the better the training, the better the accuracy, the better the decision making. So once you've achieved a suitable accuracy level, you can run your AI. The actual live decision making is what we call inference. Data is received, the AI algorithm processes that data, and a decision is made. In our example, a camera captures real-time video, AI detects a person, the car applies the brakes. The time delay between the decision and the reaction is called latency. Again, in our example, by speeding up the decision-making process, the reaction time of the car increases. Traditionally, you can speed up AI a couple of ways. First of all, the closer the AI is to the action, the faster the decision. Second, having the appropriate computer resources, faster computers, means faster AI. So ideally, AI works best when it's embedded in the device that's using it and has the suitable processing power to run it. So what's the problem? Well, AI models are complicated. Decisioning across all of that data, that inference, simultaneously requires a tremendous amount of compute power. The computer resources, the memory, the energy required to run AI is significant. You can find this compute power in the cloud, but connectivity and that time delay, that latency, becomes a non-starter in critical AI like autonomous vehicles, where milliseconds matter. You can bring this computer power closer to the edge, but it's big, it's heavy, it's expensive. The computers that have the sufficient power are very difficult to embed in smaller devices. So if the cloud is too slow and you can't put a heavy processor on a drone because it can't fly, and you need to preserve battery life, these are all challenges. AI at the edge is hard. Which brings us back to Deeplite and what we do. Well, it's really quite simple. We've created our own AI solution that can automatically make other AI more efficient. We can make AI that's way smaller, so you can embed it in the small, inexpensive hardware. We can make AI run way faster, like you saw in the video. We can make AI use less energy, which is really important with battery-powered AI and good for the environment in general. And we do all of this without compromising the accuracy of the original model. Very straightforward process for a team that's created a model for accuracy, but maybe it's too big, maybe it's too slow, maybe it's consuming too much power. You simply download our engine, point to your original model, and specify your design constraints. What size are you looking for? What power consumption? What speed? What accuracy? Are you willing to trade off any accuracy? Maybe you're not willing to trade off any accuracy. All of these inputs are specified to our engine, and you simply hit run. And then our automated process takes over. Our AI algorithm, using the original model as a frame of reference, analyzes the model architecture and resolves a brand new model architecture based on the constraints specified by the user, and generates a new optimized model based on that configuration that can now be used in production. Very straightforward, fully automated, on-premise solution for deep learning teams. One of the areas we're really excited about is what we call platform-aware optimization. The optimization I just described, where we took an 80 megabyte model, compressed it by 37x down to 2.2 megabytes, focused on the model architecture itself. These new techniques focus on the target hardware that the model is going to run on. In this particular example, it's a low precision network based on 2 bits for waits and activations, taking the model down to 137.5 kilobytes, a 582x compression. well within the zone for microcontrollers that are going to be running at the edge in IoT applications. With Deeplite, complex AI can now run on any device on tiny chips. We can embed AI in that drone, in that camera, on that phone. We can embed dozens of AI models into that self-driving car. We can get AI out of the lab and into the real world. We are Deeplite, and we enable AI for everyday life. Thank you.